In this lesson, you will learn about the pitch or secondary axis flight path modes used by the Autopilot. In most modern airliners, there will be an auto throttle system, which will operate in conjunction with the pitch channel of the Autopilot to control climb, cruise and descent functions. One of the following pitch functions can be engaged simultaneously with a roll mode: altitude hold, vertical speed hold, and altitude acquire, which engages automatically on the completion of a climb or descent. We will give a brief overview of a typical autothrottle system to appreciate the compatible modes of Autopilot and Autothrottle. When engaged, the autothrottle can maintain either a target speed or thrust value. The speed target could be an indicated airspeed or Mach number selectable by the pilot using the speed selector on the mode control panel, indicated in the speed window, and on the primary flight display speed tape. The flight management system can also command a speed target. The thrust target could be a value of N1 or engine pressure ratio, EPR, depending upon which has been designated the primary thrust setting parameter for that particular engine. The target thrust can be set manually by the pilot, or it can be calculated by the thrust computer based on standard thrust ratings for takeoff, climb, cruise, go-around, or continuous. Or, the flight management system can manage the thrust when it is controlling the vertical flight profile. The target thrust value and the active thrust rating can be seen on the engine indications on the electronic display or a separate indicator. The autothrottle is armed using the arm switch on the mode control panel. Then it can be engaged in either speed or thrust mode by selecting the respective button, also on the mode control panel. The engaged mode will be shown in green on the flight mode annunciator. The autothrottle is disengaged by pressing a disengage button on the outer part of the throttle levers. There may also be take-off go-around switches on the throttle levers, which will cause the autothrottle to engage in take-off or go-around mode when pressed. On the ground, take-off thrust will be the target, and during the approach, go-around thrust will be the target. It would be normal for this type of aircraft to use the autothrottle to manage the thrust for the takeoff, climb, cruise, descent and approach, up to the point the pilot takes control for a visual landing. If an auto land is being carried out, then the autothrottle will remain engaged up to the point of touchdown. Prior to takeoff, it will be normal for the pilot to select a speed in the speed window appropriate to the takeoff. Typically, this is V2, or takeoff safety speed, plus 10 to 20 knots. Also, an altitude will be selected using the altitude selector appropriate to the departure clearance. In this example, we have set the speed window to 170 knots and the altitude window to 5,000 feet. Selecting an altitude in this window will arm the altitude alerting system and cause the thrust computer to calculate a climb thrust value based on the altitude change. The selected altitude is also shown at the top of the altitude tape of the primary flight display. A typical climb profile would include a climb speed schedule. In this example, we will use 250 knots, 300 knots, Mach decimal 7. This means that after the takeoff, the aircraft will be accelerated to 250 knots and climb to 10,000 feet at that speed as there is an air traffic control speed restriction below 10,000 feet. After 10,000 feet, the aircraft will be accelerated to 300 knots to continue the climb until Mach 7 is reached. Then the climb will be continued at Mach 7. Initially, the aircraft will be flown manually, with the autothrottle controlling the thrust up to 5,000 feet. Then the autopilot will be engaged. The takeoff thrust will be selected by the pilot, or calculated by the autothrottle computer or flight management system. The target thrust N1 or EPR is indicated by bugs on the N1 or EPR gauges. The autothrottle will be armed prior to the takeoff by lifting up the arm switch. After lining up for takeoff, the throttle levers will be moved manually to approximately 80 to 85% N2. And the autothrottle is engaged in thrust mode by pressing the toga switches. Thrust or N1 being the annunciation in green on the flight mode annunciator. The autothrottle will now advance the levers until the takeoff thrust is achieved. After 60 knots, the autothrottle will hold the levers at that position to maintain the selected value and to prevent the system from chasing any slight variation in N1 or EPR during the takeoff. After takeoff, at 400 feet above ground level, the autothrottle N1 button is pressed, and the commanded thrust reverts from takeoff to climb, annunciated on the engine instrument display. The speed selector can be used to increase the reference speed to 250 knots. Shortly before reaching 5,000 feet, the altitude alert system will alert the pilot to the fact that the aircraft is approaching the altitude selected in the altitude window. The pilot will level the aircraft at 5,000 feet and select speed mode for the autothrottle. The pilot can maintain the altitude, while the autothrottle maintains the selected speed at 250 knots indicated airspeed. Autopilot A will now be engaged in command mode, and heading select will be the engaged function in roll to maintain the heading. With the autothrottle maintaining the speed in speed mode, altitude hold can be engaged in pitch. When the altitude hold button is pressed, the light in the button illuminates, and Alt Hold is enunciated in green in the pitch window of the flight mode annunciator. The autopilot pitch channel will now maintain the altitude, with the autothrottle maintaining the speed. These two are referred to as compatible modes. Modern autopilots will not accept incompatible modes. For example, altitude hold and N1 would be incompatible, as neither the autothrottle nor the pitch channel of the autopilot is maintaining the speed of the aircraft. The easy way to remember compatible modes is that at any point in time, with the autopilot and autothrottle engaged, either the autothrottle or the pitch channel of the autopilot must control the speed of the aircraft, this being either indicated airspeed or Mach. The only time this may not be true is during a go-around, using the autothrottle and autopilot. The altitude hold button can be pressed during a climb or descent to interrupt the climb or descent, to level the aircraft off if required. With the aircraft in altitude hold, we can now climb our aircraft to 30,000 feet. There are three ways to cause the autopilot to climb or descend the aircraft to a new altitude. We can use vertical speed mode, flight level change mode, or vertical navigation mode. Flight level change and vertical navigation modes will be looked at during the second lesson on autopilot pitch operation. So let's now look at vertical speed mode. The first action is to select the required altitude in the altitude window. This will arm the altitude alert system and also cause the autothrottle computer to calculate a value of climb thrust based on the altitude change. We are going to bypass the thrust computer and use vertical speed mode first. When the vertical speed button is pressed, the light in the button illuminates, and vertical speed becomes the annunciation in green in place of altitude hold. The light in the altitude hold button goes out. Once vertical speed mode has been engaged, the vertical speed window opens to display the current vertical speed of the aircraft. In this case, we are neither climbing nor descending, so plus and 4 zeros would be indicative of level flight. The thumb wheel can now be rotated to select the required vertical speed. Our target today is plus 1500 feet per minute. As soon as the thumb wheel is moved away from 0, the aircraft will pitch up to achieve the selected vertical speed. At the same time, the autothrottle will move the throttles forward to maintain the target speed of 250 knots. The aircraft will maintain 1500 feet per minute rate of climb at 250 knots. At any time during a climb using vertical speed mode, the vertical speed can be adjusted by moving the thumb wheel to increase or decrease the vertical speed. As the aircraft passes through 10,000 feet, the airspeed can be increased to 300 knots by selecting 300 in the speed window. The autothrottle will push the levers forward to increase and maintain the new target speed. Climbing at a constant indicated airspeed of 300 knots will cause the Mach number to progressively increase. When the Mach number reaches decimal 7, the changeover button on the mode control panel is pressed. This causes the speed window to now show the Mach number that existed at the time it was pressed, in this case Mach decimal 7. The aircraft will carry on climbing at 1500 feet per minute rate of climb and at Mach decimal 7. As the aircraft approaches the target altitude, the altitude alert system will alert the pilot with visual and oral indications. Shortly afterwards, the autopilot has to reduce the vertical speed of the aircraft to capture the target altitude. This maneuver is called altitude acquire and will allow a smooth transition from a climb or descent to altitude hold. Altitude acquire is a transitionary mode which cannot be selected, but occurs automatically from a climb or descent to an altitude hold. This occurs at between 300 and 500 feet or so before the target altitude, dependent upon the vertical speed at the time. The higher the vertical speed, the sooner it will occur. At this point, altitude acquire becomes the engaged mode in pitch enunciated by altitude acquire, replacing vertical speed. As the aircraft levels off, the autothrottle moves the levers rearwards to maintain the selected speed of Mach decimal 7. When the aircraft is level, altitude hold engages in pitch, and altitude hold will enunciate, replacing altitude acquire. The light in the altitude hold button will illuminate. Descending using vertical speed mode is the reverse of the climb. First, select a lower altitude in the window. Then select vertical speed. Using the thumb wheel, select a desired rate of descent. The pitch channel of the Autopilot maintains the rate of descent, and the autothrottle maintains airspeed. The speed can be managed in the same way in the descent, going from Mach number to indicated airspeed, then a speed reduction at 10,000 feet. Altitude acquire and altitude hold will engage when the aircraft levels off. Care is required using this combination of vertical speed and speed hold to ensure that the values selected on the mode control panel are achievable, to prevent overspeeding or underspeeding if too high a vertical speed is selected. During this lesson, you have learned about the modes used in the pitch or secondary axis, including altitude hold, vertical speed mode, and altitude acquire. Level change and vertical navigation will be covered in the next lesson.